Okay, I want to continue the conversation from class on Friday. We had gone through an activity of creating something like this, where we were creating a bar on the x-axis to represent the value of the independent quantity, and a bar on the y-axis to represent uh, the value of the dependent quantity. And we were specifically focused on how to create these bars. Well, now I want to change gears and I want to talk about what we use them for. Okay, so we're using this animation to understand about graphing in the xy plane. So we're going to take our attention off actually, how this blue bar is created and how this red bar is created, and look at what is it, what are we doing with this animation, or what's it used for. So these are representing two quantities. So we have an independent quantity that we're showing on the x-axis, and we have a dependent quantity that we're showing on the y-axis. And so we said a correspondence point was simultaneous values of two variables. So a correspondence point, so right now we have a correspondence point of the value of x and the value of y. And that correspondence point we would display that as this point right here. So when x is 5.1, and from the example in class we were saying that the y value was half of the x value, so this would be x value of 5.1 and y value of half of that. What would that be? 2.505. Okay, it would be that point. And so what happens is, with the relationship between two variables, as you change the independent quantity, so I'll change it and make it, say, something easy, 2.88. So now as x is 2.8, the dependent quantity changed to remain half of x, or 1.44. So here's a new correspondence point. And so we could pick lots of values of x, 5.52, 0.9, and get the corresponding value of y, and that determines a displayed point. Okay, so if we think about then, what's the set of all correspondence points of these two variables as they change together? Okay, well, we could think of all of these correspondence points emerging as the value of x increases, and y is always half of the value of x. Okay, so this is all these points taken together is what you're used to seeing as the displayed graph, like a line or a curve. Okay, so we've got the given correspondence point of x and y, and then this line then represents all of the previous correspondence points for values of x that were less than 1.8. So then when all of the points are shown, this is how we represent that. This is the displayed graph of all of those ordered pairs of correspondence points. But when we see this is what we see in textbooks all the time. We see like a swept out line or a swept out curve, like you would sweep with your pencil. But when we see this, we need to think this. Okay? Whenever you see a graph like this, you think this. All of the correspondence points of the simultaneous values of the two variables, in this case our x variable and our y variable. So let's use that idea to practice sketching. So I'm going to change, instead of y being half of x, I'm going to use this more complicated, a little more complicated polynomial here. And we are simply going to, let's see, I want to zoom out. There we go. So we don't need to know what that is, but just in case you're wondering, we're doing this polynomial, negative x to the fourth over 20 plus x cubed over 4. And we're going to use this idea to try to sketch the graph ourselves. So I'll set the variables in motion here, changing together. Just run it forward only. Okay, so here we're showing two quantities, and maybe this is time in hours. So let's put some actual real world premise on this. Maybe this is x is time in hours after midnight. And maybe this, our y coordinate is the temperature in the freezer in degrees Fahrenheit. Okay, so we have a malfunctioning freezer here. That it's as these 6 hours go by, we have the temperatures fluctuating, and we want to express this relationship with a graph, which is all the correspondence points of these two variables, and we want to display that. Okay, so remember that. We're going to look at all the correspondence points as they're displayed on our graph. And so let's just take, so at midnight, temperature in the freezer was 0. So go ahead and draw that. And then we'll let a little time go by. Maybe a little less, do about halfway. Okay. And at this time, it looks like it's still pretty close to 0. Let a little more time go by. And now we have the temperature is rising in the freezer. Let a little more time go by. Temperature is still rising. Now it's up above 2 degrees. Still rising. So the idea is so imagine tracing with your finger on that point. And as you trace with your finger, you're going to get all the correspondence points. And then we just imagine that graph emerging, point by point. And if we, like I said, if you imagine putting your finger on that point and sweeping it as x increases to sketch all the correspondence points. I'll do my best here. Our temperature in our freezer profile here looks something like that. So that would be based on how these variables are changing together. That's the displayed graph of the two quantities changing together. So let's see how I did. So here's the computer doing it instead of me. Okay, pretty good. And then here's the version you're more used to, a sweeping curve. And so if we were to graph that curve statically, showing all the correspondence points, it might look like that. Again, this was time in hours. This was degrees Fahrenheit. And remember, when you see a graph like that, you think that. You see that, you think that. Okay, one more example. So here's another relationship between x and y. 3 sine 3 sine cosine x. Okay, here's showing that when x is 0, when x is 0, the value of y is 2.5. I'll just go ahead and do that. So we imagine all the correspondence points emerging. I'll just show just the two bars representing the values of simultaneous values of the two variables. Okay, and now I'll show the point, the correspondence point displayed for each of those. And if you imagine putting your finger, you could even do it on your screen right now. You could put your finger on that point and just hold your finger on that point and sweep along. And that's creating the displayed graph of all the ordered pairs. All the correspondence points. So I'll try to do it with my pen. Come back. All right, here we go. A little wobbly at the end. Okay, so let's show there. All the correspondence points emerging, being displayed. And then it's easier, it's more convenient to sketch it this way instead of plotting every point by hand, right? So this is just a more convenient display of many, many, many points. So how did I do with my sketch? Pretty good, just a little shaky hand at the end. But remember, you see this and you think this. You see this, and you think this. All the correspondence points of the two variables, the simultaneous values of the two variables taken together as we choose to increase our independent variable. Okay, I hope this gives you a little deeper insight into what you're looking at when you're looking at a graph. See this, think this. Okay, have a good weekend. I'll see you on Monday.